Hello everybody, welcome to the statistics class. Today I am going to take a topic today my topic is regression. This is for third semester students of Osmania University. In the previous class we have dealt with the correlation. Correlation means it's a relationship between the linear relationship between two variables x and y. X and y. And the correlation tells you how the values are related. Whether the values of x are related positively, x and y are related positively or negatively. That means if the value in x increases, the value in y also increases, then we call the relationship, the linear relationship between x and y are perfectly positively correlated. If the values in x increases and the values in y decreases, then we call them as they are negatively correlated. So, if the correlation between x and y is 0, then we say that there is not a linear relationship between x and y. There may be some other relation but not x and y. So, the intensity of the linear relationship between x and y is spoken in correlation. Today we will see what is the regression. Regression means it's a mathematical analysis between x and y. So, what is it? We will see how we are going to see the regression, how we are going to frame a mathematical analysis. But regression literally means the meaning of regression is the average, stepping back to the average. What does that mean? If x is the height of the father and y is the height of the son, then the height of the father, let us see, father is 5.5 and the height of the son would be 5.7. If this son becomes father and his son's height would have been 5.9. If he becomes father, his son would have been 6.1. Now, if he became father and his son's height would be 5.6. If he became the father, the son's height would have been. That means what? Over a period of time, there was increase in the heights of the son, but it is not continuously increasing. In the nature, whatever it is, it will come back to its average. So, again 6.1, if the father's height is 6.1, the son will not be 6.3. Then, our heights would have been somewhere near, it would have been, we would have been touching the sky, but it is not happening. In the nature, however, the father heights or the son's heights, they will revolve around the sun. That means you go high, but again come back to the average. So, the mathematical relationship between x and y are that. That is called regression. Now, to find the regression at the mathematical value, we have to derive the regression line. How do we do that? Let us suppose that in a bivariate distribution xi comma yi, where I will be taking the values I is equals to 1, 2, so on up till n, y be the dependent variable and x being independent variable, let there be a bivariate distribution xi comma yi, where I is taking the values 1, 2, so on up till n, and in that y is dependent variable, x is independent variable. Then line of regression on y on x is given as y is equals to a plus bx. So this is dependent on a bx. So this is dependent variable, and this is constant, and this is slope, and this is independent variable. So this is the data bivariate frequency distribution xi comma yi, where I is taking the values 1 to n, in which y is dependent variable because y is dependent on a plus bx, and x is independent variable. So the regression line on y on x is given by y is equals to a plus bx, in which y is dependent, a is a constant, b is the slope, and x is independent variable. So this whole thing is called as regression equation on y on x. Now how do we derive regression equation y on x? Let us start. So first is, let us suppose that we have bivariate distribution xi comma yi, where I is taking the values 1 to n, and y is dependent and x is independent as we said, and let the line of regression of x on y be, what did we say? Y is equals to a plus bx. This is the regression line on y on x be this. Now, according to the Lagrangians, the principle of least square is given. Applying principle of least square, we will get the normal equation. So, summation over I yi is equals to Na plus b summation over I xi. This is equation number 1. Summation over I xi yi is equals to a summation xi plus b summation xi square. These two are called normal equations. If y is equal to ax plus b is a straight line, if we want to find out a and b, we will apply principle of least squares given by the Lagranges. In that principle of least squares, first we have to form the normal equations. So these are the normal equations which we will be using to find the values of a and b. Now divide equation 1 with n. So what do we get? 1 by n summation yi is equals to plus b by n summation xi. So we have divided the equation 1 with n. So these two will get cancelled. 1 by n summation of yi would be y bar a plus b 1 by n summation xi. So that would be x bar. What is this? This is the line of regression y on x passing through x and y. Now this is, let us say, this is a straight line. Y is equals to a plus bx passing through the values x and y. Now this is also a straight line which is passing through x bar and y bar. So this is the equation of a regression line passing through x bar comma y bar. Now covariance of x comma y. What is covariance of x comma y? This we call it as equation. Covariance of x comma y is nothing but 1 by n summation over I xi yi minus x bar y bar. So x bar and y bar. This implies 1 by n summation over I xi yi is equals to covariance of x comma y plus x bar y bar. So what I have done, I have brought this here and covariance term this side and plus with that. Now this is called equation number 4. Equation number 4. Also we have sigma x square 1 by n summation over I xi square minus x bar square. That implies what? 1 by n summation over I xi square is equals to sigma x square minus 6 x. This is equation number 5. Now, first we have written equation of a straight line, and by applying least square methods we got two normal equations. Why are we applying least square method? To find the values of A and B. So we have taken two normal equations stating them 1 and 2. We have taken equation 1 and divided by n we have done. So we got y bar is equal to a plus b x bar, which is the regression line passing through x bar and y bar. So now we know this. What is covariance? Covariance is 1 by n summation xi by I minus x bar y bar. From that we got this term, and sigma x square is equals to 1 by n summation xi square minus x bar square. So this x bar square also we have got. Now consider equation 2. Consider equation 2. What is your equation? Summation over I xi yi xi yi is equals to a into summation over I xi plus b into summation over I xi square. Now multiply both sides by 1 by n. What do we get? So it will become 1 by n summation over I xi yi is equals to a by n summation over I xi plus b by n summation over I xi square. Now what is 1 by n summation over I xi yi? 1 by n summation over I xi yi would be that. Now, using equation 4 and 5, we get, what do we get? 1 by n summation is this, equation 4 is equals to covariance of x comma y plus x bar y bar is equals to a 1 by n summation xi would be x bar, a x bar plus 1 by n summation x square, that is equation 5, b into sigma x square plus x bar square. This is equation number 6. First we have taken y is equals to a plus bx, and this straight line curve, to get the values of a and b, we have applied Lagrange's principle of least square and got the normal equations. We stated the normal equation as 1 and 2. Then we have considered the first equation and divided by n. So we got y bar is equals to a plus b x bar, which is again a straight line passing through x bar and y bar. That we called it as C. And we also know that covariance of x comma y would be 1 by n summation over I xi yi minus x bar y bar. So the simplified value is this, and we are saying it to be 4. Then sigma x square, which is 1 by n summation over I xi square minus x bar square. That also we have left hand side terms, we have made it into summations of xi's and yi's, or summation x or summation x square. Then we have considered normal equation number 2. In the normal equation for the normal equation 2, we have multiplied both sides by 1 by n. We got this. Now we have substituted the values from equation 4 and equation 5 in the normal equation 2. Then we got equation number 6. Now, covariance of x comma y is equal to x comma y plus x bar y bar is equals to ax bar plus b sigma x square plus x bar square. This would be your equation number 7. Now take or consider equation 3. We have taken equation 1 and multiplied both sides by 1 by n, and we have simplified and set 3. Now equation 2 we have taken, we have simplified, we got equation 6. Now we are taking equation number 3. Now consider equation 3. Y bar equal to a plus b x bar. So now multiply, now consider equation 3 and multiply by x bar. So what we are going to get? X bar y bar is equal to ax bar plus b x bar square. This we call it as 8. We don't take that. Now, subtract equation 6 from equation 7. Subtracting equation 6 from equation 7, we get, what is, we are subtracting equation 7, subtract equation 7 from equation 6. So put the equation 6 on the top. Covariance of x comma y plus x bar y bar is equal to ax bar plus b sigma x square plus b x bar square. And equation 6 would be x bar y bar ax bar plus b x bar square. So now we have to subtract. So x bar y bar cancels, ax bar, this and this is cancelled. we are left with covariance of x comma y is equals to b sigma x square. B sigma x square. Now, therefore, B is equal to covariance of x comma y by sigma x square. Now, what is correlation is equal to? We know R is equals to covariance of x comma y by sigma x into sigma y. That implies covariance of x comma y is equals to R into sigma x into sigma y. So, put the covariance value in the B. B is equals to, therefore covariance of x comma y would be R into sigma x into sigma y divided by sigma x square. Now this will get cancelled. That implies B is equals to R sigma y by sigma x. This B we call it as, B is the slope. So we call it as regression coefficient. Regression coefficient. And it is denoted by the equation we have started with y on x. So we will write y on x. This is the regression coefficient of y on x regression line. Now, since the regression line passes through x bar comma y bar we have started with, then the regression line would be y minus y bar equals to R into sigma y by sigma x into x minus x bar. This is the regression line passing through x bar and y bar with the slope. For that we call it as regression coefficient R into sigma y by sigma x. Similarly, if our equation x bar minus y bar passes through x on y, that is, if your value x on y it passes through, then similarly regression line of x on y would be x minus x bar is equals to R into sigma x by sigma y into y minus y bar. So, there will be two lines of regression always. One is x on y, the other one is y on x. X on Y means what? X is dependent and Y is independent. Y on X means what? Y on X means what? X is dependent and Y is dependent and X is independent. Here X is dependent and Y is independent. So these two lines are not one and the same. Substitute, if you find out this X this way, that way, it doesn't work out. There is a difference in the equation. What is that? Why do we have two lines of regression? We will see later. But as for now, we will have two lines of regression. One is for Y on X and the second one is X on Y. So these are the regression lines now. So there will be always two lines of regression, Y on X and X on Y. So what is the regression line Y on X? So Y minus Y bar is equals to R into sigma Y by sigma X into X minus X bar. And this part we call it as B of Y on X regression coefficient. And X on Y equation would be X minus X bar is equals to R into sigma X by sigma Y, Y minus Y bar. This is the second regression line on equation which is different. You see the difference in the equations, and this part we call it as regression coefficient. B of X on Y. So these two coefficients are different. We will have two coefficients in regression, and we have four properties for these coefficients. What are they? Let us see. First property, the relationship between correlation coefficient and the regression coefficient. R is equals to root of so the correlation coefficient is the geometric mean of two regression coefficients. That is the first property. And the second property is, if one of the regression coefficients is greater than 1, then the other regression coefficient is always less than 1. So if one of the regression coefficient is greater than 1, the other regression coefficient would be less than 1. Third one is the arithmetic mean of two regression coefficients is equals to correlation coefficient. And fourth property is the coefficients of regression are independent of origin but not scale. So these are the four properties of regression coefficient. Properties of regression coefficient. So these are the four properties of the regression coefficient. Now in the next class we will see what are the differences of regression and coefficient. Till then, if you have any doubts, you can contact me. Thank you.